Thank you, Francesca. Thank you very much. So, colleagues, I'm just doing a bit of the intro here on all the work that we've been doing in UNHCR on climate-related risks in general. You are aware of a lot of background documents and strategies. The most recent of which we worked on last year is the Strategic Plan for Climate Action 2024-2030. There's also, of course, the Operational Strategy for Climate Resilience and Environmental Sustainability 2022. This year is the last year for its implementation until 2025. We've been chasing many of you to report on a lot of the targets that are set within the operational strategies. Both these documents really highlight and state the importance of working on climate resilience settlements that combat or try to mitigate the risk of our most pressing hazards. So the most common hazard that UNHCR responds to in our settlements is floods, and overall, not just in settlements, but even in urban settings, namely, for example, last year, Brazil, Ethiopia, is floods by 35%. And in general, in terms of our beneficiaries, 70% of refugees and 80% of IDPs, they originate from countries on the front line of the climate crisis, making them really increasing their vulnerability and sometimes causing secondary displacement. So we can go to the next slides, Emily. Yeah, here you can. Okay, Emily, next slide. So it's all right. So this work on flood risk management flow really started through the Geneva Technical Hub initiative, which is a joint initiative together with Swiss Humanitarian Aid and UNHCR that brings Swiss academics and expert practitioners to find technical solutions to operational problems. A lot of you have interact with our GTH experts, interact with also our academia partners through testing, through exposure to the different products we've worked on in the last 3 years. Through on-site and remote field support, operational advice, a lot of the tools and products from the last 2 years on technical guidance are also produced through the GTH. And the last is all the initiatives on staff capacity building, which also through this project, a few webinars, capacity building initiatives also took place throughout the last year. So through the presentation, Emily will start guiding you through the presentation. This is a very open presentation. It will take around an hour, so I encourage you, if you have any questions, don't hesitate to put it in the chat box or even raise your hand throughout, because we'll jump through diverse themes, so don't hesitate to come in at any moment. Emily, I hand over to you.
Here, thank you, and sorry for my technical problems. Here I will. So my name is Emily Schmidt. For the one who don't know me, I'm one of the settlement planning expert from the Geneva Technical Hub, and today I will present you this workflow for the flood risk management. What's actually a workflow? This is kind of a methodology, a step-by-step methodology that help technicians in the field to go through the different steps necessary to build or develop a strategy for the mitigation of the impact of flood. So for the structure of this presentation, we have passed through the introduction. Now we'll explain a bit the history of the project and the methodology for development and improvement of the project over the years. And then together with my colleagues, Andrea Cipa, our flood expert from GTH, and Nadine Antonon, our researcher from the Zurich Technical Institute, through each of the main step of this workflow. Then once this is presented, we will have a feedback from the field with Henri-Daniel Evanet from the head of the field office in Béthou, who will explain a bit his experience of this project. Then we will explain shortly what materials and tutorials are available before we head to the question and discussion. You can feel free to stop me in between to ask for questions, or me or someone else in between to ask for questions. But since I'm sharing my whole screen, I don't see anything, so maybe you will have to interrupt me or something like this. I'm sorry for this. So how did this project happen, and what was the methodology for improving it? The history is like since 2022, which is nearly the starting of the Geneva Technical Hub initiative. We have been collaborating with the Technical Institute of Zurich in this question of management of flood risk. In the first 2 years, this applied research project has been producing what we call the flood risk mitigation toolbox, which is composed by three main components. On one side, we have a kind of catalog, the compendium of mitigation measures, who presents different mitigation measures with technical drawings and applied examples and some criteria. Then we developed also a plugin, so a add-in for GIS to map the risk and the assets at risk. And the third component was the guidance for local data collection. So not to work only remotely, but also how to be able to organize workshops and different methodologies to collect information in the field. Then to operationalize this toolbox, we have been working on it over several plans. So already in February 23, we had Geneva Technical Hub joint training on climate-related risk mitigation in Geneva for both shelter and settlement officer and WASH officers, where you have here some images of it. And we talked about this toolbox already, and that was still in the making. Then once we had the finalized or the first finalized tool in February and March 24, we organized online training and testing of this flood risk toolbox with different participants, from like 7 to 12 participants, depending on the sessions, from 4 country offices. And we also presented the project several times, either online on webinars or during the 2 last regional trainings in Nairobi and Dakar for shelter and settlement officers. So what we took from it is that definitely flood events are frequent and they have a high impact on the refugee sites. So there is a high interest and a high need for this. But to operationalize the toolbox, there was missing a part about hazard definition. So we decided to develop methodologies for this. For remote analysis and hazard mapping, and then also to develop better our methods for local data collection. So that's what we did in 24. And in October 24, we made a piloting of this flood risk methodology in the site of refugee from the 15 Avril in Béthou in the Republic of Congo. So the Republic of Congo is in Central Southern Africa, and has Betou is in the complete north of this country, in the middle of the primary forest, and has this is a small village along the Ubangi, and suffers from recurrent flood events. Like every 4 years, about they have flooding, and the intensity and the frequency increase also with the climate change. So after the last big flood event in December 23, where nearly half of the site of the refugee site was completely underwater, and large part of the small city were also underwater, with very important impact on displaced and host communities. The country office of Congo Brazzaville decided to ask for Geneva Technical Hub support, which was also the possibility to test all this methodology for flood risk mitigation. So we had, on one hand, like before going over the site, we could do preliminary remote analysis using the methodology with different open source data. And then we could roll out the systems, the methodologies for local data collection on the site, together with the field officers and also with the population, who was greatly participating. And then back from the field mission, we developed final maps and developed a strategy remotely together with the country office in the field office in Betou. So in terms of outputs from this pilot, for Betou itself, we could analyze the situation of flooding and propose a risk mitigation strategy for them. And at the same time, it was the occasion to verify and to adapt the tools and methodologies through this case study. Then the case study that we have now with the Betou pilot is also used as an example. For example, today in the presentation, so we will talk a lot about Betou. And the main result of it is that we could adapt all this and develop this 6 steps workflow for flood risk management. So this workflow is based on integrated geomorphological method. So it means it's not much about modelizing software, but more on observing the terrain and how it works. And in the workflow, we also have a lot of documentation, user guides, and video tutorials that help to support this. Now we'll start with presenting this workflow, this methodology. It's here. So you see, we have 6 steps here, 6 main steps. The first one is the context analysis, so to prepare a base map. Then the remote analysis helps to understand the hazard, so how much flood, how often and how much flood happen in a place. Then the field assessment will help to collect local information on the hazard and on the mitigation measure to be able to correct this. So once you arrive at this 3rd step, you will then be able to finalize the hazard map. Maybe before I go further, I need to explain differently. So you have the main steps, with each of step has a range of actions that gives an output, so a kind of product. And for doing this, there are several tools and guidance that have been developed to help the technicians working on this. So if I go back from the context analysis, you can develop a base map. Then from the remote analysis, you will be developing an indicative hazard map based on remote data. So it means that you will use different data that you can find freely on the internet to make a first idea of the hazard. And then in the field assessment, you will be able to verify all this, collect additional data while engaging with the community to understand a bit their local knowledge. And this will help you to adapt the maps to have a final hazard map, which is verified on the spot. Once you have this, you can cross-check the hazard with the buildings and the different assets which are on the site that you look for, to identify the assets and define their risk according to the vulnerability of the asset, means how much damage will it make if they are flooded, and the criticality of these assets. So depends what is the impact if the service is not functioning anymore. So defining the asset at risk will give you a risk map and also a list of priorities. So which is the first thing that you should do to mitigate the risk. Then you can go to the mitigation scenarios in the step 5, which is defining the different measures and seeing which one would be adapted, the best adapted to mitigate the floods. And combining different measures will help to have the best scenario. You can also then, from the mitigation scenarios, you can see their impact in redoing the step 4 to see with a different hazard, how much risk do we have, how many assets at risk do we still have when we do a mitigation measure. Once you have the different scenarios, you will compare them with cost-benefit analysis or different possibilities of comparing them, estimate the cost, estimate the impact, and then compile all information to propose a strategy. This strategy is then an advocacy tool that can be used for inform the decision makers so that they can have the best decision. Once the strategy is decided, you need also to prepare an action plan. So the strategy document would be the second main output of this workflow. Now, the methodology, it's not an automated system. It's a kind of way to structure the work so that it's easier for the technicians to work on it. But it needs the technicians' input, the technicians' knowledge of the terrain, of the context, to have a good result. And the workflow also relies quite heavily on GIS. It's made for QGIS because it's a free software. So it needs a certain expertise, but we also have developed a crash course for the people who don't know QGIS previously. So you can take the crash course with exercises, and then it will allow you to use this workflow. But most of it, this workflow relies on common sense. So it's important to think about the reality and not apply blindly the workflow. It's just a tool to help you go further. Now, to explain the different steps, I will leave the word to our flood expert, Andrea Cipa, who will explain the 2 first steps of the workflow, which are preparing the base map and analyzing flood hazard.
Thank you very much, Emily, for your perfect introduction. So we are going to speak about the first step. It is about the context analysis. The main output of this context analysis is to prepare base map. So what does it mean? It means we need to capture as many information as possible about your area of interest. We can start with human and infrastructural factors like settlements, just to understand what type of settlement do we have, rural, urban settlements. And these also give us a little bit a link to the population density of the settlement. In the settlement, we have shelters. It's not just important to know where those shelters are, but also it's important to understand what type of shelter, what is the use of those shelters, maybe a hospital. So to see the different importance of those shelters. And then to that, still in the human factors, understand where are the transportation network, and again, not only the location of the network, but what type of road do we have, primary road, secondary road, what type of condition are the road, do they have drainage, do they not have drainage, and then all other possible information like a water supply, sewage system, and existing flood protection infrastructure. All this information are partially already available on internet. You can find them, and you have to map them. I will come later. Additional to that, still in this context analysis, to have a good picture of the situation, you need the geomorphological factors. You need to understand where, how is the nature built, where are the rivers, where is the surface, where is the surface water, what type of soil do we have, what is the land use, how is the land cover. So all this information is available in internet, and they are free accessible. So I just would like to give you the links. For example, we have Google Imagery, historic Google Imagery, we have GIS Imagery, we have Esri Imagery, we have OpenStreetMap Imagery. Everything is free available. You might ask your operation to organize a high resolution satellite imagery. This is very much possible today. And all this information needs to be gathered together into the GIS software. And through that, we will be able to build our base map. In the material, you are going to find the tutorials, the help how to develop this type of base map. Once you have these factors collected, you need to go to the next slide, please. You need to go to the topographic factors. The topographic factors rely a lot on the digital terrain model. The digital terrain model is nothing else than a representation in 3D of the terrain. Also, this information, this document is free available online. It's just matter to understand and to know how to take it. It's not difficult. Through this digital terrain model, you can understand already the elevation of your area of interest, the slope gradient. Of course, if the area is flat, you might have flood. If the area is steep, you might have erosion. You see, for example, in the map on the left about our site, 15th of April, we have contour line of every 20 centimeter. It shows clearly that the area is extremely flat. On the other map on the right, you see a representation of the digital terrain model with colors, where you can see low land and high land in relation to the level of the river. So next page, please. Yes. And then once you have collected all this information that, again, I repeat, you can do it at home, not going out of your office, you have to start to analyze those information. Partially, this analysis is already done, but we can speak about a global analysis. And this global big data analysis is not always very well done. The resolution is bad, but at least you can see, for example, in these images, you have a global analysis of the water flooding in Betu every 100 years return period. So this gives you a little bit already a kind of small idea how is the flooding occurring in the area of interest, but we want to have more precise, more high resolution analysis. Please, next slide. And we take our elements that we have collected in step number one. We start with our digital terrain model. Through this digital terrain model, we can develop a so-called watershed analysis. A watershed analysis is nothing else than the study of the terrain, and it gives you, as a result, the location of the streams, the natural stream that will occur in case of rain. So water goes downwards, and suddenly it becomes a stream and then a river. So this location is very important for us to know, because this is the area where most probably flooding will occur in case of rain. And not only this is important to know, but also the watershed. The watershed is nothing else than the extension of the area of influence. So the area that influence your spot. So it doesn't make sense to make any type of mitigation measure too far from your location if this mitigation measure do not influence somehow your area of interest. So the watershed is the area of influence in terms of water of the site. Next slide. Then also through this digital terrain model, you can identify, like I was showing, the lowland. And of course, the lowland in relation to the river is the area that is going to be flooded first in case of water level rise of the river. And not only, but in very flat area, you can as well identify so depression, sinks. You can imagine that it rains a lot. The terrain is not taking the water. So in this lowland, in this sinks, water will just gather, and this is actually flooding, and you cannot build there, or you have to make something in this location. So next slide, please. So you can see on the left side. Okay, no problem. On the left side, you can see. Okay, you can see on the left side the riverine flooding. So the flooding that might occur when the river water rise, water level rise. So we have the lowland and highland. And then on the right side, you can see the sinks or the depression in those areas. So when it rains, we are expecting that water stays there. Just what to tell you, the precision or of these maps depends fully in this case of the quality of the digital terrain model. But nowadays, digital terrain models that are free available are not perfect, but still good enough to have an idea, a realistic idea. Next slide, please. And then you have the next step. It is the remote sensing. Remote sensing is nothing else than picture taken from the satellite. We can speak generally about two types of picture: optical picture, so normal, or radar-based picture. In both cases, we are using the two system. Radar-based picture are actually better because they have the capability to look through the clouds. And as we know, during a flood event, mostly the weather is bad, and that's why radar-based imagery, it gives a better result. But in case that there is no cloud, also optical imaging is not bad. And we are focusing on especially two types of satellite, the Sentinel satellite. Those satellites are actually performing ideally for us because they have several cameras, and those cameras, through several band combination, they have the capability to extract exactly what we are looking for. So if you are looking for bare land, they have the capability to extract the bare land. In our case, we are looking for wetland, we are looking for water, so we can take the picture and extract just the water. And not only that, those satellites, they frequently revisit the same place, sorry, and they are on the orbit since 10 years. So we have the possibility to access the images that have been taken in the past. So for the last 10 years, we have images almost every week, at least one image. And this is a very good thing for us because we know that in Betu, for example, the flooding was occurring in December 23. So that's why we go to in this period and we just take those pictures in December and 23. You can see here, for example, the image of 18 of December 23 taken with Sentinel-2, which has an optical camera. So the flooding at that day, it was like you can see in the image. So you can take all the flooding of December and then combine those areas and finally get the whole extent of the flooding. On the right, you can see the Sentinel-1, another satellite which rely on radar-based images. And this was taken on the 25th of December. It was impossible, for example, to take the same image with Sentinel-2 because it was cloudy. So we can gather together all the images that are available for December and 23 and finally develop a realistic flood hazard map based on that day. The positive point is also that all these images are freely available and not so difficult to download like it sounds. It is actually very easy. There are several tools. Some are more difficult than the other one, but again, in the material, you will find the tutorials and the explanation how to do that in a very easy and easy explained way. That's it. So finally, it's important. One other thing, the negative thing about this satellite image is that the resolution you can go back maybe. The resolution of the image is not that good. It's not in the resolution that you can find, for example, Google Earth imagery. But still, you are around 15 to 20 meter per pixel, which is not good. So you cannot identify a shelter, a car. But for flooding analysis, this quality of resolution is much more than enough. So next one, please. Now, at this point, you have understand that you have plenty of maps, plenty of layers. You have your base map, you have your flood map based on the digital terrain model, you have your flood map based on the satellite images. It is matter to combine all those maps in a final, sorry, not final, but preliminary flood hazard map. Why preliminary? Because we have not been yet into the field. We cannot verify, we are not sure that those information is correct, but at least we know that most probably floodings occur in this and this and this area, and we can, once we are in the field, know what we have to look for, where we have to go. That's why you develop this preliminary flood hazard map. You make nice printout. This will be the base for your field-based survey, and additional you can upload this preliminary flood hazard map in your GPS or mobile phone. That will guide you in the field to find the right spot, to verify that what you have seen previously from the office, it makes sense or it has to be adapted. And with these tools, you are ready to go into the field, and Nadine goes to the field.
Actually, Emily, for now.
Sorry.
So here, Emily goes to the field again, armed with her GPS and her mobile phone. I saw that there is already a question in the chat. If it is okay, I would keep this question for the end of the presentation, because I think it's interesting to develop a bit the answer to this. So then you arrive on the step 3. So remote analysis, as we said, it's good, but it's not sufficient, because sometimes the data you can get on the internet are not up to date, or they are not accurate, so they have errors, or they are not precise enough. So you need to verify and to complete the information with field assessment, so you can modify the preliminary map according to the local information you have taken. So in the field assessment, there are two main actions, let's say. You have the technical observations that you will do, so observe the terrain, the natural feature, the human footprint, and also the witnesses of the past flood events. And the other main part is to engage with the community, because they know better actually what happened to them. So we have developed a guide for local data collection with different ways of collecting this information by the community. It will also help engaging with the community. Will also help them to get aware of the problem of the study and of the possibilities for mitigation. So if people are included in the process of identifying and proposing a strategy, it will definitely work better, because the strategy will be more adapted to what the local people need. So the output of this is this final hazard map. So it comes from the preliminary hazard map that you have now on your phone or GPS, that will be adapted with the local info you collect. And for this, you have different tools. I will go of them now. Here. So the first part of field assessment is observing the terrain. For this, in B2, for example, we had someone making a detailed topographical survey to complete and to correct on the digital terrain model from FabDem that we have taken from the internet. so that we had a better precision, and we could also correct the errors and provide some profiles of the terrain to see if what kind of drainages would be possible in this very flat terrain. On the other hand, the technicians we were went over the land again with our map, observing the terrain, marking flooded areas and measuring flood heights to know a bit better what was flooded and how was the flood events of December 23. To be able to geolocalize all this information and then to use them to adapt the map afterwards, we use this application on the mobile phone called Avenza Maps, which you see here, which has actually the background map you choose from in the background of your phone, and then allows you to geolocalize any points you want to do with comments and additional pictures, so that you can remember what you have been seeing and also see the way, like the path you have been walking over. Then observing the terrain was one, and engaging with communities would be the other main task and place, because since they know best what happened, how they were affected, and often they already had the first ideas for mitigation measure, they already developed some solutions themselves. So in the case of Betu, we conducted semi-guided interviews. It means interviews with open question, both with affected people from the host community and from the refugee site, and also with local experts. Local experts would be long-term inhabitants or people who are working in the technical office of the authorities, or different people from the authorities who have different ways of seeing what happened, or from NGOs, like any kind of people who have been affected and who had to deal with the consequences of a flood event. And another way to collect information from the population themselves is to organize participatory mapping workshop. So here in Betu, we had a full day of workshop where in the morning, when you see in this image, we went through the refugee site with the participants to the workshop, so that everyone could get acquainted with how do you see a map and how do you look for a map. So we visited the house of every participant, and they had to put on the map where was their house. Then we took a picture, and we could keep this map here with all pictures of the participants and the place they were. And afterwards, each of the participants made mental maps of their casual ways to go to the main activities they have daily, and what was impeded by the flood, and where was it the most flooded. And from these mental maps, they had in small groups to translate them in the real map to define the most flooded areas. So in the end, each group had a kind of hazard map according to their own information, so that we could specialize their own information and their own knowledge of the situation. Now, once you have all this information from your terrain observation, from the terrain observation here from Avenza, here you have the result of the topographical survey, and here the results of one of the group from the planning workshop. You put them all together on GIS, on your preliminary map, and you adapt the hazard map so that it corresponds with the reality you saw in the field. And this brings you to the first of the main outputs of this workflow, which is the contextualized flood map, flood hazard map. So that's the map which shows which zones are the most flooded, which zones are flooded but a bit less, and which zones are not flooded or less flooded, like they were not, in this case, they were not flooded during the event of 23. They could be flooded if for the centennial flood, for example. It doesn't mean that it never happens, but it has less probability. Now, with your final hazard map, you will be able to consider, identify which assets or which buildings are at risk, and which mitigation measures would be useful. So for this, I will leave the word to Nadine Antonen, who will explain step 4 and 5.
Yes, thank you, Emily. So I take over with step 4. As Emily said, step 4 is about the assets at risk and how to identify and prioritize them. So in this step, the most of the work will be done by the use of QGIS and the plugin, which has been developed in the project as part of the toolbox Emily introduced at the beginning, and by using a flood risk analysis matrix to prioritize and look at the criticality of the assets at risk. So the output of this step will be a risk map with all the assets at risks and also a list of priorities. But let's go step by step. Next slide. So to identify the assets at risk, the QGIS plugin can be used. So the plugin is a small program that can be loaded into the QGIS, which is a freely available software. And this plugin appears in the software with these 14 blue buttons you see on the top right, which you go through in order to identify your hazard, vulnerabilities, and consequently your risk. So to come back to the definitions, the hazard is basically the flood itself, its characteristics, and also the magnitude of the flood, for example. And the vulnerability is the impact of the flood on infrastructure and people in your settlement. So the tool combines the two and calculates a risk map, like the one you can see on the picture, which is for a settlement in Sudan. Next slide, please. So here you can see the risk map as a result of the plugin from Betu. You see all the residential buildings in orange and red, which means high risk and very high risk. So this is kind of the identifying the assets at risk combined with the hazard map you saw before as a result from the step 3. On the right side, you see then the table, which really comes up with exact numbers of buildings at risks, which is also a result of the plugin. Next slide. After identifying these risks, there is another tool, this flood risk analysis matrix you see here on the right side, very small. This will then help you, based on the risk map, to prioritize even further. So according to criticality or importance of the asset. If you have, for example, a list of 700 buildings, this matrix will help you to prioritize and identify the most critical assets, as for example, a hospital. With this information, you can then define the order of the intervention or the type of mitigation scenario. Which brings us then to the next step, step 5. In step 5, you develop mitigation scenarios in which you combine adapted measures to your case. On the right side, you see an example of a mitigation measures as you find them in the compendium of mitigation measures, which is a catalog of 22 measures for flood risk mitigation. This is also available on the website. We come back to that a bit later as well. But first, we go back again to the QGIS plugin. Maybe you can go to the next slide, where at the end of the 14 steps in the plugin in QGIS, you can select important aspects for a possible mitigation strategy, which you see here on the left. For example, you can choose the type of intervention. If you want the measure being engineered or nature-based, you can choose the scale of your intervention, the effect duration, is it a short-term strategy, is it a medium-term strategy, and also you can choose the costs and so on. After selecting these characteristics, the plugin will then come up with recommended suitable measures for your case. As you can see on the right side, this is kind of the result beside the map. The tool at the last step gives you these recommendations for your case. And then, based on that, on the next slide, is where we come back to the compendium, which is, like I said before, this catalog of 22 measures for flood risk mitigation. And in this compendium, there's 5 categories. There is measures for water flow management, there's measures for surface water management, measures for adaptation of buildings and other assets. There is measures for nature restoration, nature-based measures, and there's non-build measures and capacity building, and which also includes early warning systems, for example. So with the recommended measures from the QGIS plugin, you can analyze the measures with this compendium and further define ideal scenarios for your case. Next slide, I think. So, for example, in the case of Betu, we defined measures for a short-term scenario, such as small-scale drainages, where you see on the right side also in the pictures, also measures like protection layers and or early warning systems. And we developed more long-term scenarios or possibilities would be a network of drainages and retention basins around the settlements, combined with infiltration measures. So yes, exactly, now I forgot almost. And with these kind of strategies, you can then go back in the tool and adapt as well your risk map. This is like a possibility. You can then go back and say, for example, we build a dam on one side of the settlement, which is it's not the case in Betu, but then you can kind of estimate the effect on the assets at risk and then change it and see how many buildings less are at risk, for example. So this is kind of the going back and adapt your risk map again. And with that, I give over back to Emily for step 6.
Here, I'm back. So step 6, now you have compiled kind of all information, analysis, and compared the different scenarios for mitigation to see how efficient they are or how much impact they would have. It's the moment to compile them all in one strategy. So first, you can compare the scenarios, the estimate implementation cost, time, feasibility, efficiency. So you can propose the best strategies, and you compile then all information in a strategical report that you can present as advocacy tool or as awareness raising tool also. And once the decision maker have taken the decision about the strategy to implement, then it would be the time to prepare an action plan with a timelines for implementation so that you know who will be responsible of what and go further. So this last step, compiling everything, brings to the second main output of the workflow, which is the strategy, and also will allow for an action plan. Before deciding on a strategy, you can use a cost-benefit analysis to compare the different scenario. So each scenario is composed from different project components. Here in this example of the matrix, you have one scenario who said early warning system and elevated shelters as measures. Another one who say, there is only one, we only make a big dike. And on the third one, you make early warning system and build a big dike. So all these three scenarios are compared In this, you decide, you calculate how much are the costs, both the investment cost and the annual cost for the given duration, let's say 10 years or 20 years, depending how you are counting. Here it's 10 years. And then you also calculate the benefits. On one way, you have the financial benefits, is the reduction of damage, of cost of the damages per year or over 10 years. And then you also have the human benefits, which are difficult to quantify, but then it's the number of people who would be affected if you have nothing, compared to the number of people who would be affected with the mitigation measures. So this cost-benefit analysis allows to define, on one hand, the most efficient scenarios, the one which has the best ratio benefits versus cost, the scenario which has the most impact. And in the case of this matrix, you can see that the most impact is here because it has the most impact on the people. You have 95% reduction of the human affected, and also the most damage reduction in terms of cost. So it brings the most benefits. Then you can also define the cheapest scenario, because sometimes the priority is that you don't have enough money. So in this case, then the scenario 1, which is costed that much and allows to spare that much, is less expensive, because in total you will over 10 years, let's say, earn or like spare $400,000, but you need to invest less than in this scenario where you will spare less money in the end, but then spend more at the start. So this cost-benefit analysis helps you to compare the scenarios and to decide according to this what is best suited for the operation. Then you compile everything in this a strategical report. Here's some extract of the strategical report of B2. You give, on one hand, the main result of the analysis with maps, with tables and explanations. Then you propose the strategy, which is most of the time multi-component, because you will probably propose to you can implement measure at small and at larger scale, and for the short term to have directly an impact, but also for the long-term prevention to reduce durably the risk of floods for the next events, but the next and the next and the next afterwards. And you will probably work on different axes. You can reduce the risk by reducing the hazard magnitude, or you can reinforce the assets so they are less vulnerable, or you can implement nature-based solutions which will have several impacts and are not engineered but more working with the nature. And much can also be with behavior change, so non-structural solutions such as early warning systems, escape route, and awareness raising. Then the strategy will also include the possible partnerships that you can find. And once you have decided, or once the decision maker had decided on a decision, then followed by an action plan or completed by an action plan. As I said already, the strategy can be used as an advocacy tool. You can present result and strategy to the authorities, to the different possible funding partners, so to be able for them to have enough information to take the decisions about the strategy to implement. And it can also be used as an awareness raising tool. So you can organize information and awareness raising sessions with the local population so that they know a bit how to behave in the case of the next flood to limit the impact and to limit the way they are affected. So now we concluded the explanation of the step 6. I guess it was quite a lot to take. It's 3 years work, so at some point it is also quite technical and quite a lot of information.